Hello and good afternoon, CSI258 Section 847 students for the second 8-week term in the spring 2015 semester at Anne Arundel Community College. This evening's Packet Tracer tutorial is going to be on Packet Tracer Activity 5.3.1.4, where we're actually going to get an opportunity now to verify and troubleshoot an existing NAT configuration. So as you can see to the right here, we've got our addressing table. And let's take a look at the scenario. So we have a contractor has restored an old configuration to a new router running NAT, but the network has changed and a new subnet was added after the old configuration was backed up. It's our job to get this network working again. So let's go ahead and try to ping server 1 from PC 1. And is it asking for PC 2? Pull each of these down here. And laptop 1 and laptop 2. So we'll get those into the folder. We'll start with PC 1 here. So we're going to pull up our command prompt, and I'm simply going to say ping 64.100.201 dot, and the server is 5.5. So I try to ping from PC 1 behind switch 1. And it looks like we're going to time out here, because my guess is the reason they're asking you to do this is to confirm that you do not have connectivity right now. So it doesn't look like it's working for PC 1. Let's go ahead and check PC 2. So I'm going to say ping 100.201.5. And if PC1 is unable to get out, then the assumption here would be that PC2 is probably suffering from the same challenges, and it looks like it is. So let's check on the laptops here. So we'll say ping 64.100.201.5. Do we have any luck on the laptops? And I'm pretty sure that this is going to be broken connectivity as well, and so just for completeness here, we're going to say ping 64.100.201.5, and my guess is that laptop 2 is also going to fail. So it looks like right now all of our connectivity is broke, and it's probably all going to center around router 2. But let's take a look. Let's see what's going to happen here. So it says verify or view the NAT translations on router 2. So we have, look at these subnets here, 10.4.11 and 10.4.10, right? Because I'm going to make this a little larger here so we can see some more real estate. And let's go ahead and bring that up a little bit more. So we're on router 2. We're going to go from user exec into privilege exec with the enable command. And I'm simply going to type in, we'll do a show run here. It wants to see, the NAT translations, show Ip Nat Translations, and there are none right now. So if the NAT table was working, we would see translations here, and it's clear that we're not seeing anything. And again, we had no connectivity, so something's definitely broken here. So show the running config. So let's do a show run here, and you can see on router 2, and look for those serial interfaces. So there's serial interface 000. Now this interface is addressed with an inside global IP that happens to be in a /27 subnet. Now, if this is the internet-facing interface, serial 000, and this IP is correct, and let's scroll up here, let's take a look on router 2, serial 000. Do we have the right IP address? We do. However, what do you see here that is backwards? That's probably not correct. If you keyed in on the IPNAT inside command, you're absolutely right. Because is this the inside local RFC 1918 addressing interface? It is not. This is the inside global addressed interface, which is going to have publicly routable IPs on the internet. So you can see right now, we'll make a little note here to the side, that serial, actually let me go ahead and do this on the screen. So we're going to say that, and where will we put this? So we'll do it here. So serial 000 should be IP NAT outside, right? So that's the first thing that we see. Let's go ahead and continue down here, and we'll do Control C there. Whoops, bring router 2 back into the fold. All right, let's continue down. So serial 001, that's our inside facing IP, right? That's our inside local IP, and it's a /30. So let's do the first thing we should do is confirm our IP. So 10.4.1.2, and as you can see, it looks like the serial interface 00. Oh, I'm sorry, I'm on the wrong router there. 10.4.1.1. Okay, it was up one too many. So 10.4.1.1. So the IP is correct. Our subnet mask is correct. However, just as you would suspect, if we had the IPNAT inside command here incorrectly, it looks like we've placed the IPNAT outside command here incorrectly, because again, this is our inside local interface, right, with RFC 1918 addresses. So we're going to go ahead and make a quick note over here that on serial 0, make sure I get this right, 001, it should be IP NAT inside, right? Not outside. Should be IP NAT inside. And then let's kind of continue our investigation here. So we found two problems right now that are definitely going to be challenges when doing NAT. All right, so now we're going to roll up upon the dynamic. Yep, so we're doing dynamic NAT here, and now we're rolling up onto the pool configuration. So let's take a closer look here at this pool configuration. So IP NAT pool, R2 pool. So we're good so far. That's my starting IP address, and you can tell just by looking at this that that is not a network ID, right? Because it's odd. Your subnet ID or the network ID is always even. So what this statement is saying is, inside my dynamic NAT pool, which is a /27, which is a .224, I want to make available the addresses starting from .195 up to .223. So let's come on over here and let's do some of the math here, and let's figure out what the entire subnet is going to be. You can see it shows it's a /27 starting at 192. So if it starts at .192 and the block size is going to be 32, the next address is going to be .224. So really what this is saying is I want you to use the addresses between 195 and 223, and I apologize, I want to put that in a different light there. So there we go. So 223 is going to be my broadcast address. The next network segment would be 224. The next network ID is going to be 224. So all of these addresses in here, right, we can pick from these. So it started with .195 and it ends at .223. So we're saying use all the addresses from .195 all the way up to .222 inclusive. And that's a pretty good range of addresses there. Far more addresses than we require for the 4 PC/laptops that we have on our internal network. In fact, this is about 27 addresses here, right? So, are we okay here? Is this going to be okay? Well, let's find out, because we saw two different ways to do this. The first was you put the network ID here, and then you put the broadcast address here. Well, you can see the broadcast address is here, right? This isn't the network ID. So what this means is .193, .194 are not to be used in the dynamic NAT setup. So we could change that to a 2, right? And that would still be, that is a legitimate way to represent the range of addresses we want to use. And it's got the correct net mask on here. And again, iOS does the math on this and says it's going to figure out for itself, if he's saying 195 to 223, then and it's a /27, it'll do the math and figure out, oh, he's referring to this subnet right here, or this network right here. And so that's why we're starting at 195 and ending at 233. But we're going to check and see, because we may have to go in there and make an adjustment. So I'm going to make a small note over here. We're going to say change .223 to .222, because that's a legitimate change. Okay, let me go ahead and try to back up here. And well, actually, it's going to pull those out of the way. So I don't want to wipe out. See how far back it'll let me go. Yeah, we're not going to be able to go far enough back, so I'm going to do a Control-C, and we'll continue on. Whoops, and there is the previous video wrapping up its export. All right, so let's continue on here. So now we've got IP NAT inside source list 101, pool R2 pool. Now, is that a standard access list number? Where does it end? Does it end at 99? Well, we're going to take a look at that. So it looks like the ACL, and let's take a look at that ACL. So here it is. Access list 101 permit IP for the 10.4.10.0 any, right? So you could use, right, it looks like from at face value here, it looks like this would work for that network segment. But do we need an extended access list? We don't, right? So we're looking at the running config. We can see assign the IPNAT inside and outside commands to the correct ports. So let's go ahead, and I'm going to actually clear the screen here because we've got some of these things in the way. And then we're going to walk ourselves down, because we've seen that it looks like there's clearly a number of errors. So let's go to global config with configure terminal. And I'm going to say interface serial 000, and we're going to say no IPNAT inside, because the serial 000 interface should have IPNAT outside, right? And then let's go into the serial 001 interface and say no IPNAT outside, because that's not the outside facing interface. We're going to say IPNAT inside. So we've corrected the inside and the outside NAT statements on router R2, which was step 3. And now it says ping from the server. So let's try to do that. Let's go up here to the first server. Can I ping? All right. Well, I can ping from 10.4.10. PC1, how about PC2? And PC2. Right, so the NAT statement is functional. So we've corrected the inside-outside. We've recorded the success. However, let's take a look here. If I go up here to ping, it's probably not going to work, because we saw that ACL, and we'll take a look at it again here in a second. Let's confirm we can't ping from either of the 10.4.11 laptops, and we cannot. And the reason that we cannot is because only the 10.4.10 is being allowed in the access list that is associated with the pool. So what this means is the router, again, the router looks at the traffic when it hits the R2 inside interface, the IPNAT inside interface. It looks at that inside local IP, the source IP, and checks to see, is that IP allowed to create a dynamic NAT mapping from an inside local to an inside global address. And the answer here for the two laptops on the 10.4.11 subnet is no. They're not allowed to. So it's going to probably have us here. It says view the NAT translations on R2. So do show IP NAT translations. And it looks like I may have waited too long. So let's actually run the ping again here and run the ping again here. And we'll take a look, and there we go. And that's what we're looking for. Let's stretch this out a little further, trying to get it so that it drops. There we go. So it drops them onto one line. So you can clearly see here that the 10.4.10 PCs are not having any issues at all, right? That they are successfully creating the inside global, or I'm sorry, the inside local to inside global mappings. All right, so we've recorded the success. We've looked at the NAT translations on R2. So let's do show access list 101 on R2. So do show access list 101. And as you can see, we've got a series of matches. However, this access list is not permitting the 10.4.11 to participate. So it says the wildcard mask should encompass both the 10.4.10 and the 10.4.11 network. So correct the access list. It wants us to delete the access list, replace it with a similar list that is also one statement in length. The only difference should be the wildcard mask. So, and again, you typically see just the standard access lists used here. So I'm just going to say, well, actually, I want to see in the config here. So we're going to say no access list 101, right? And you'll notice here that we still have the statement referring to 101. So we're going to wipe this out as well. So I'm going to say copy, and we're going to say no, and we're going to paste it in there. So now it's asking us to create an access list. Does it tell us? And replace it with a similar list that is, so it says similar, but it doesn't say that it has to be access list 101. So I'm trying to determine here if it's going to expect that. So we'll try access list 1, and let's see what happens. So it wants a single line. So we're going to say permit 10.4 dot, and we could do, if it's going to allow that, and I guess does it say only those two or make sure it's those two? Should encompass both of those. So we'll go with, we'll see if it's looking for kind of the lazy way to do this. So we'll say 10.4.00, and we're going to put in here a /16, because that definitely encompasses both of the 10.4 networks. So access list 1 permit 10.4.0.0 and 0.0.255.255. Now we deleted it and recreated it. It did not bump the points. So I'm wondering if it's looking for, let's make sure it's not looking for that 101. So we're going to say access list, and we'll go up into the extended range 101, and we'll say permit 10.4.0.0, and we'll use the correct, and I'm sorry, permit, what are we permitting? IP, and we're going to say 10.4.0.0 0.0.255.255 to any, and we're going to leave it at that, and let's see if it was looking for 101 to match, or if it doesn't want exactly 101, it may be looking for, let me make sure, with a similar list that is also one statement in length. The only difference should be the wildcard mask. All right, let's drop that statement back in here that references 101 to see. Let's see if that's what it's looking for. Let me read on here. For the success of each ping. So it doesn't appear that it's looking for the 101, or it could be that I'm just giving it too large of a range there on the 10.4. Let's see what it might be. And it's not going to give us any help there, so that's okay. So let's refine the access list as it stands now. So the wildcard mask should encompass both. Well, our wildcard mask does, but it doesn't like our wildcard mask. So delete 101, replace it with a similar list that is also one statement in length. The only difference should be the wildcard. So it's definitely going to be something to do with the wildcard for the ACL. So let's do this. We're going to say no access list. Let's try to hone in on a little bit closer of an access list. So if this is 10, and did I make sure 10.4? Yeah, so if we're looking at 10.4.10 and .11, right? And these are /24s. what kind of a summary would I need here? So let's work this out. So we're going to look at the interesting octet is the third octet, right? So 10 in binary is going to be 1, 2, 3, 4, and then it's going to be 8, 2, and not the 1. So that's equal to 10. And then 11 is going to be 4, well, we'll get the 4 zeros that precede it here. 1, not the 4, that would be 12, 10, 11. And that's equal to 11. So the first 8 bits match here. The first 8 bits match here. We've got 9, 10, 11. I'm sorry. So we have 16 bits that match. 17, 18, 19, 20, 21, 22, and 23 bits match. Right? And that bit right there does not. So it's a /23, which is going to be .254.0. So 255, our subnet mask for a summary, would be 255.255.254.0. So if I were to get the wildcard mask out of here, I would simply subtract that from the all 255s, which would be 0.0.1.255. And so again, I commented earlier, I took the lazy way out thinking, oh, maybe we can get away with just blowing it wide open here with a /16, but let's see if it's looking for only those 2 subnets to be included, which would be a wildcard mask that looks like that. So let me back up here. There we go. Whoops, 255. And that would be the wildcard mask. So make a note over here. All right, so we'll do Control C. Okay, so let's go ahead and recreate this access list. So this is going to be .1.255. And 10.4, and actually I need to work out the IP real quickly here because it's going to be 10.4. Now remember, it's going to be 10.4. What? Well, we've got matches out here that values that are on, and the first value that's on is the 8, the second value is the 2, so 10.4.10.0/23. That is our summary, and with only 1 bit not matching, we know that this summary is an exact match for these 2 networks and only those 2 networks, because you take the number of bits that are left over that don't match, right? 2 to the 1 is 2. So we are going to have 2 networks that this wildcard mask is going to identify, and it is those 2 right there. So we're going to look at the 10.4.10. So let's bring this back here. So where are we at here on the line? So it's going to be 10.4.10, and this is going to be as exact as you can get. And again, I apologize there. It wasn't quite clear from the reading that that was what they were looking for. So let's go ahead and let's enter this in. Access list 101, permit IP 10.4.10.0 with a wildcard mask of 0.0.1.255. And so now this is going to, again, kind of take us further down the path to see, is that what they were looking for? Or are they expecting, and that certainly was what they were looking for, as I'm glancing over here to make sure. And just wanted to make sure that what they weren't looking for was delete this extended access list, only to now then flip it and make it a standard access list. All right, so we had some heavy lifting there on the access list, and that could have been a little tricky because, again, it said the wildcard mask should encompass both the networks, right? But it doesn't say and only those networks, because this wildcard mask and that declaration there, that's correct. That is certainly going to match 10.4.10 and 10.4.11. However, it's also going to match about 1,000 other subnets. And you could clearly see after we worked it out here that what it's really looking for, it wants us to be very precise in our access list match, and we've just done that. So now let's verify connectivity here. From PC1 we should have no problem, PC2 should be no problem, and now let's pull the laptops into the fold, and these guys should be able to get out as well. And as you can see, it's working, right? And there we go. Let's get router 2 back up here, and let me save the config just in case, and we're going to say show Ip Nat Translations, and let's make this a little taller. And as you can see, we definitely have a large number of translations. The 10.4.11s are now included, right? So you can see our inside locals, and you can see the inside globals to which they are matching. Now, you'll notice that it's not giving us a random high port, right? It's just simply showing a much lower number because it's not. This does not represent the port. It represents the count of the dynamic mappings that have taken place. And as you can see here, we're using 197, 198, 199, 200, and so it's just going to continue to go up in order, keeping in mind that when we have our statement, which is, where's our pool statement at? Where's that pool at? Here we go. This is what we're looking for. You can see that we've got a large range of addresses. And again, remember, I could have put 222 there. That would have worked, right? Because I didn't have to put the broadcast address there. I could have given the range of addresses and only the usable addresses. So it's always something to pay close attention to, because they'll try to get you oftentimes by maybe not putting the network ID here with the expectation that you're going to be, you see the broadcast address and you're like, oh, well then this should be the network ID. Not the case, right? Remember, what this pool statement says is this is the first usable IP address. That's going to be the last usable IP address if and only if it's not the broadcast address that would be in that subnet. And that's where it can be a little tricky, right? You are not going to have a NAT translation for 223 because that is the broadcast address. It'll stop at 222. All right. Well, this was a really good activity on troubleshooting dynamic NAT. You'll notice that we didn't have any static NAT here, and we also didn't have any NAT overload, or AKA PAT, port address translation setup. So that concludes Packet Tracer Activity 5.3.1.4, verifying and troubleshooting NAT configurations. All right, thanks for watching, and see you on Saturday.